using identities to solve equations. So previously in this chapter, we actually solved simple trig equations. We actually did some factoring to solve some trig equations. What we're going to do in this section is just using identities to solve trig equations, because if I can't factor, then maybe there's a substitution that I can put instead. So if I look at class example number 1, it says solve the following equations where x is between 0 and 2 pi. So if you look at A, I have 2 cos squared plus 3 sine x. What's the problem with this equation? So if I write it like this. What's the problem with that? Okay, if there's no problem, how do I solve it?
Well, it's not a difference of squares, and you can't really factor it.
Why can't I factor?
You don't know. Well, you can factor, but you don't know how. Yeah, there's no constant term.
There's no common term. I have cos and I have sine. So that's like trying to factor an xy equation. I can't factor those. I can't solve those equations. So what do I do? Can I write cos squared x or sine x in another form? It is the cos squared x. So on your formula sheet, where do you see cos squared x?
It can be written as sine, 1 minus sine squared x.
Right, so cos squared x can be written as 1 minus sine squared x. I can rearrange the Pythagorean identity. So if I rewrite that or put in that substitution, how does that change things for me?
Then you're just working with sine.
Now I'm just working with sine. I now have a common variable. So if I remove the brackets, I get negative 2 sine squared x plus 3 sine x plus 2 equals 0. So I kind of rearranged things as I was expanding it out. Do I like factoring when I have a negative out in the very, very front? So what could I do to get rid of that negative? Divide everything by negative 1. So then I get a positive 2 sine squared x, a negative 3 sine x, a negative 2, and everything equals 0. So now I can look at trying to factor this. So how do I get 2 sine squared x? If I multiply 2 sine x and sine x, that's going to give me my 2 sine squared. Then I need this negative 2. So how do I multiply, what two numbers multiply together to give me negative 2?
2 and negative 1 and 2.
So 2 and 1, one has to be positive, one has to be negative. And I have to put it in such a way so that my middle term is going to be negative 3. So where do I put the 2 and where do I put the 1?
The 2 should be negative. It should be opposite of the other 2. And then plus 1.
So there's my negative 2. And then I get a negative 4 sine x and a positive sine x. Now if either one of these equals 0, the whole thing equals 0. So I can let each factor equal 0. So if 2 sine x plus 1 equals 0, what does sine x equal?
Negative 1/2.
Negative 1/2. And then we're right back at the point where we've gone through these already. So to solve sine x equals negative 1/2, what do I need to do? Inverse of sine, and when I do inverse of sine, what do I get? What'd you get?
Aren't you supposed to put it as an absolute value?
Yes, has an absolute value. So when I put it in as sine inverse 1/2,
You get like 0.5235.
okay, and then how do I change that into that radian, that pi mode?
Oh, you divide it by pi.
Divide by pi,
And then it's a fraction.
and what fraction do you get?
Pi over 6.
Pi over 6. So that becomes my reference angle. So how does that help me find sine x equals negative 1/2?
Find the quadrants.
Find what quadrants. What quadrants is sine negative?
2 and 4.
So now if I was to picture this, I'm going to make it squishy right here. Quadrant 3, quadrant 4. There are my two reference angles. So in quadrant 3, what is that going to be equal to?
7 pi over 6.
And how'd you get 7 pi over 6, Rachel?
It's going to be pi plus the pi over 6.
So pi plus pi over 6. And what about in quadrant 4?
11 pi over 6.
And how do I get the 11 pi over 6?
2 pi minus pi over 6.
2 pi minus the pi over 6. Good. Okay? So now I've got sine x minus 2 equals 0, which means sine x equals 2. And what do I get for a reference angle?
An error.
Why?
Because can be more than 1.
Sine can't be greater than 1, so there's no solution. That's the abbreviation for solution, SOL and then an N, and sometimes you can put a line underneath the N. So there's my solution, 7 pi over 6 and 11 pi over 6. Okay, so let's look at the next one. What do I have right here? I have cos x plus pi over 6. Where have I seen that before? Now what do I have? I have cos A plus B. So cos A plus B becomes cos A, cos B, minus sine A, sine B. And then I have another cos A minus B. So I'm going to put a minus, and then I'm going to put a square set of brackets in there so that I know I'm subtracting the whole thing. So what is cos A minus B?
Cos A, cos B plus sine equals sine.
So cos x, cos pi over 6, plus sine x, sine pi over 6. And that's all going to equal 1. What's cos pi over 6?
root 3 over 2.
Okay? So I get root 3 over 2 cos x. What's sine pi over 6? So minus 1/2 sine x. And I already know this is now root 3 over 2, so I have minus root 3 over 2 cos x. Minus this positive, so then I get minus 1/2 sine x equals 1. So if I go to collect my like terms, what is root 3 over 2 cos x minus root 3 over 2 cos x? 0. They're gone. And negative 1/2 sine x minus 1/2 sine x. So in other words, a negative 1/2 plus a negative 1/2. Negative 1. So I get negative sine x equals 1. So what does positive sine x equal? Okay, now I want you to finish it and find out what the solution would be. Okay, so sine x equals negative 1. So find my reference angle. What's my reference angle? Pi over 2. What quadrants am I in? 3 and 4. So in quadrant 3, what is x going to equal?
3 pi over 2.
And in quadrant 4, what is x equal?
3
3 pi over 2. So there's only the one solution. Good. Okay. Class example number 2. Says, consider the equation 4 minus 7 sine x equals cos 2x. So if I look at this, where do you think I'm going to have to make a replacement? The cos 2x. And when I go to make my replacement with cos 2x and I look at my selection, which selection, because cos 2x has 3, which one do you think I want to use?
Maybe the 1 minus 2 sine squared.
And why would I want to choose that one?
Because it's kind of in the same form as the other side.
Because now I have sines, right? Whereas the other two forms of the cos 2x has a cos in there, and that's just going to bring in another step, okay? So this is the most efficient. So I get 4 minus 7 sine x equals 1 minus 2 sine squared x. So what would I do to solve this equation?
Do you move the x to the other side and the constants to the other side?
So let's move everything to one side. Which one do I want to move? Do I want to move the left to the right or the right to the left? Look at your squared. Is your squared positive or negative? So let's move it over. So if I move it over, I get a positive 2 sine squared x minus 7 sine x. When I move the 1 over, it becomes negative, and when I combine it with 4, I get negative.
Oh, wait. Move the 1.
Move the 1 over, I would get positive 3. Okay? Now what would I do?
Factor.
Factor it. Okay? How would I factor this?
Sine x minus 1 times sine x minus 3.
So I get 2 sine x and sine x. That's going to give me my 2 sine x squared. Okay? How do I get 3?
3 times 1.
3 times 1. Now I have to figure out where do I put the 3 and where do I put the 1? So I'll get the 6 and 1. How do I make it a negative 7?
They're both negative.
Make these both negative. Good. Okay? So now I have 2 sine x minus 1 equals 0. So what would sine x equal? 1/2. Okay? And I have to go through, in order to solve this, I need my reference angle. So what's my reference angle for sine x equals 1/2?
Pi over 6.
Pi over 6. But this time, I want a general solution. So, first of all, I still go through, I still figure out what are my solutions in the first 2 radians. So, in the first rotation. So, quadrants 1 and 2. What is x going to be in quadrant 1?
Pi over 6.
Pi over 6. And what is it going to be in quadrant 2?
5 pi over 6.
5 pi over 6. So my general solution is going to be taking pi over 6 and then adding a multiple of 2 pi n, because that's when I'm going to end up back at that spot. And then I do the same thing for 5 pi over 6.
So, would you the key for the vacuum stack between the point seconds?
Meat, cheese, and crackers. That was some legit food. And there's like spaghetti and like pizza and burgers and stuff. That'd be so cool. You could all sign one time because you're just calculating.
Okay? And then the 5 pi over 6, same thing. And then n has to be an integer. Okay, now let's look at this other one. Sine x minus 3 equals 0. I get sine x equals 3. Is there a solution for this? No. Why not? Because sine can't be greater than 1. Okay. So your questions, 1a, 2, 4,